Good morning. So far, what we'll be seeing over now, we have seen about the introduction of measurement, and then what is sensor, what is instrumentation so far. So today, what we are going to see it of, we are going to see about an applications of measurement. So we'll be having of an three different applications. One to be the monitoring of process and operation. Second one to be the control of processes and operation, and third one to be the experimental engineering analysis. So let me see one by one. The first one to be the monitoring of process and operations. Okay, so we'll have a certain applications of measuring instrument in order to have a monitoring function. Okay, so what we'll be doing in the case of a monitoring, it simply indicate the value or the condition of parameter. So it simply indicate the value or condition of parameter at a point. At the same time, they will be indicating the readings, but they do not serve any control function. So just it will be shows the reading or the value over on it. So for example, let me consider an ammeter or an voltmeter. So what does it do? It will indicate the value of current or voltage. So that will be being monitored at a particular instant. Okay? So similarly, when we are using of an water and electric energy meters, so which is installed at home. So what we'll be using, we'll be keep tracking of used volume so that later the transfer used volume of water and energy which can be collected from the customer by the distributor. So when you are saying about an monitoring of process and operation, so it does only the functions of monitoring. So just it will be simply indicating the value or the condition of parameter at a point or one. Okay. This is the first application. So when you are saying about the next application, so we'll be having often control of processes and operations. So in order to make a control, we'll be seeing over it. So I think so we can able to see the block diagram over here. So what does it indicate? So we'll be giving an input signal. So input signal which is given to an amplifier. So that what we'll be having over it, we'll be amplifying the input signal. Then it is given to an actuator. So it is nothing but a sensor. So this is a non-electrical will be converted into an electrical quantity so that we will be getting off an output. Okay. So the input is fed by an amplifier and then it is given to an actuator and then finally we'll be collecting the output over on it. Okay. So that from the output we'll be getting the feedback or we'll be using of an measuring instrument. Okay. So if that output will be fed to an input signal. So what is the measured from the output value, which will be fed to an input signal. Now what does it does? So the thing is to be that we'll be having of a comparison between the input and the measured output value. So if there is a deviation or if there is a difference between the signal, so that will be given to an error signal, will be given as an error signal. So that will be rectified and finally we'll be getting off an output over here. So this process will be used for control and for its operation. Okay. So this is the process this takes over here. The next when you are saying over here, so this is the explanation. So the input is reference which corresponds to the desired value of output. Okay. The input is compared with the output with the help of an comparator. Okay. The output is a non-electrical quantity which is converted into a corresponding electrical quantity by a transducer which are connected in the feedback loop. So if there is a difference between the input and output, the comparator will generate an error signal. The error signal is amplified and then fed to an actuator which produces power to drive the control circuitry. The corrective action has performed till the output is same level as the what we have given as an input value. So at this stage, there is no error signal is generated by the comparator and hence there is no input to the actuator and the control action stops. So this is the process which is behind in the case of a control operation. The last one to be the experimental engineering analysis. So in order to find the solution for the engineering problem, theoretical and experimental methods are available over here. Apart from that, in order to test the validity of theoretical prediction. Third thing, in order to determine the system parameters, variables, and performance indices. Okay? For development in important spheres of study, so where there is an ample scope of study over it. So finally, in order to have a solution of mathematical relationship with the help of analogous. So these are all the experimental which will be carried out by means of the measurement over there. So in order to find the solution for the problem, in order to find the validity of the prediction, in order to determine the system parameters, in order to have a development in important spheres of study. So in order to find the solution of mathematical relationship. Okay. So the next, what we are going to see it of Abhina, we are going to see about an what about generalized measurement system. Okay. So in this case, so we'll have a simple block diagram which indicates the values of which indicates the generalized measurement system over here. Okay. So what does it does? So what is the block? What are all the blocks over here? So these are all the functional elements of a generalized measurement system. So most of the system will have a three main functional elements. What are the three main functional elements? One to be the primary sensing element, which is nothing but your physical element. Second one to be the variable sensing element, and third one to be the data processing element. So these are all the three processing elements. These are the three functional elements for a generalized element. Okay. So let me see one by one. The first one we are going to see about that. So apart from that, we'll be having often variable blocks over on it, variable conversion, variable manipulation, data transmission, data processing, data presentation. So how does this generalized measurement system work? It helps to understand how a measurement system works. Okay, and apart from that, it is comprised of a typical elements of a measurement system. Okay, so this is about the introduction about the generalized measurement system. So let me see one by one. So when you are saying about an primary sensing element, actually the quantity under measurement which makes its first contact with the primary sensing element. So hence the primary sensing element to be an transducer. So this transducer converts measurement into an analogous electrical signal. Okay, the primary sensing element receives signal of the physical quantity which has to be measured as an input over there. What does it does? It converts the signal to an suitable form. It is to be an electrical, mechanical, or other form. Okay, so that what will happen? It becomes easier for other elements of the measurement system to either convert or manipulate it. So the output of the primary sensing element may be electrical signal of any form. It may be a voltage, a frequency, or some other electrical parameter. Okay. The next block is to be the variable conversion element. So what does it then over here? It converts the output electrical signal of the primary sensing element, which may be a voltage, frequency, or some other electrical parameter, to a more suitable form without changing the information content of the input signal. It is used only if necessary. Okay. So when we are saying about the output of the primary sensing element to be the electrical signal, because the transducer converts into an electrical signal. So we know that it may be a voltage, frequency, or some other electrical parameter. Okay. But this output is not suitable for this system. Okay. So the function of this element is to manipulate the signal presented towards preserving the original nature of the signal. Okay. So for the instrument to perform the desired function, it may be necessary to convert the output to some other suitable form while retaining the original signal. Some nonlinear processes like modulation, reduction, sampling, filtering, chopping. So these are performed on the signal to bring it to the desired form to be accepted by the next stage of measurement system. So consider an example. Suppose output is an analog signal form and the next stage of system accepts input signal only in digital form. So what we'll be using over here? We'll be using of an A to D converter which converts analog into digital signal. So this process of conversion is called signal conditioning. The signal conditioning includes many other functions in addition to variable conversion and variable manipulation. Okay. The next, so in fact, the element that follows the primary sensing element or measurement system is called signal conditioning element. Suppose in case data to be recorded. So recorders like magnetic tape, high-speed camera, and TV equipment, CRT printers may be used over there. And similarly, for control and analysis, we'll be using often microprocessor or computers. So the final stage in a measurement system is known as an terminating stage. Okay. Next one will be the variable manipulation element. What is this? The main function of variable manipulation element is to manipulate. Okay. it manipulates and amplifies the outputs of the variable conversion element. The signal is presented toward preserving the original nature of the signal. Here, manipulation means a change in numerical value of the signal. It also removes noise if present in the signal. For example, an electronic amplifier accepts a small voltage signal as input and it produces an output signal which is also voltage but of greater amplitude. So thus here a voltage amplifier which acts as the variable manipulation element. Okay. The next block is to be the data processing element. So we know that is the information conveyed must be in the form of a intelligible to be the person. So the above function is done by the data presentation element. Okay. So data processing is an element is an important element used in many measurement systems. It processes the data signal received from the variable manipulation element and it produces the suitable output. Apart from that, it may be also used to compare the measured value with the standard value to produce the required output. Okay. The last one to be the data transmission. So when the elements of an instrument which are actually physically separated, it becomes necessary to transmit data from one to another. Okay. So the element that performs this function is called a data transmission element. Data transmission system is simply used for transmitting data from one element to another. It acts as a communication link between different elements of the measurement system. So some of the data transmission elements used here are to be the cables, wireless antennas, transducers, telemetry systems, etc. And the final block to be the data presentation element. So the information about the quantity under measurement has to be conveyed to the personnel handling the instrument or the system for monitoring, control or analysis process. So this function is done by data presentation element. So here it is used to present the measured physical quantity in a human readable form to the observer. It receives process signal from data processing element and presents the data in a human readable form. LED displays are most commonly used as data presentation elements in many measurement systems. In case data is to be monitored, visual display devices are needed over here. These devices may be analog or digital, indicating instruments like ammeters, voltmeters, etc. So far, what are all things we have seen today? So we are seeing about what about the applications of measurement over on it, and then what are the functional elements of an generalized measurement system. Okay, so the next thing we'll be seeing in the next class